Okay, 12. Here we go. Start with limit. X approaching 0 of f. You have to write that, otherwise the grader doesn't know where you're headed. So, questions? Please.
No, sir.
Is it like the grader would know? You just have to like.
Yeah, the grader doesn't assume.
Okay.
Yeah, hey. It is literally like a court of law. Like you have to state it.
Okay.
You can't make the assumption. And you have to remember that you do not have the ability to walk up to the grader after the test and go, this is what I meant. The grader will not, yeah, you've got to show it. Now, a lot of people have been asking like, how much to show, and I've been trying to illustrate that you can skip a lot if you can do it in your head. There's nothing wrong with that. But your argument has to follow a logical sequence. So, 2 more. Okay, cool. I can't do this because x is not approaching infinity. So I'd look to see if I can factor. Hands up. Who can see how to factor? Hands up. First thing to always look for is something easy to take out before you do anything complex. Let's go Cade 9.
The X.
And it only helps to factor if you can do the same top and bottom, to be fair. If you can't do the same top and bottom, it's not going to help. So can we do the same top and bottom, Cade?
Yeah.
Excellent. If your hand was raised, give yourself 2. Cade gets 3. And we are doing left and right. Hey, yeah, don't ever forget, we are doing left and right. Okay? So hands up, what do I write? Hands, come on. I'm going to write on the next line. Somebody new here. Let's go. Ike Hansen.
I write x multiplied by negative 4x squared plus x plus 6.
Raise your hand if you would have said what Ike just said. 2 more, 3 for Ike. Please, Luke.
I thought there was like a negative in the first part, but you had to take the negative out.
Oh, what you're remembering is, hey, if we go to factor this piece here, I would want to try and get rid of the negative, and better yet, even the negative 4 if I could. I haven't kind of got that far yet, so I just kind of go one step at a time. 2 more. So the bottom's going to be similar, like this. Questions?
Can't we just put the same x, like just have both, like take out the same x, so it's just maybe in the center? In
the
front,
center.
in the center, yeah, if you're taking an x out of both sides.
Like in front of the fraction.
What,
Not
tell
do
me
that.
what you want. Tell me exactly what you
So
write.
like if you
Just tell me what you write.
write x and then the fraction after it, instead of taking.
Oh, like that.
Yeah, yeah.
Gotcha. No, that would be very different.
Okay.
Because, 2 points though. That would be like x over 1 multiplied by whatever is left over here. This is x over x multiplied by whatever's left.
Okay.
Yeah, distinctly different. 2 more. Anybody else? Please. Oh.
So why can't we just make it more simple at the beginning and like with this 6x and 2x, why can't we make that like 3x and x, and with the negative 4x cubed and the 2x cubed, make that negative 2x cubed and x cubed, and then do the take out of x.
Are you saying to divide
Yeah,
like this kind of thing?
yeah, and then take out an x.
So ticket for Colin, look up. Everybody look. That is a common misunderstanding. It's okay. But that's what I'm paying you to bring it up. No, listen, hey, no, it's really important that you bring it up.
I'm listening.
Okay, because everybody does this. But it is a common misunderstanding. Hey, for the purposes of, look at me, look. I can do a lengthier explanation, but the short answer is simple. In this class, don't ever try to divide terms. If you're dividing terms, you're doing something illegal. At least 99% of the time. Like it's wrong. Like a simple example would be this. okay? What's the numerator really? Say it. What's the numerator? Say it.
11.
What's the numerator? Say it. Really?
17.
Louder.
17.
17. What's the denominator? Say it. 11. So the absolutely correct answer is 17 over 11. If I try to divide terms and I go like this and like this, what do I have? Like, what do I now write that this is equal to?
4. It's illegal.
It's illegal. It doesn't work. I don't know if that helped at all. Pretty good? Really, I want to establish the idea. Everybody look at me, look. Like, seriously, the idea that, yeah, I don't care if you have right answer, wrong answer, whatever. All I care is you just keep talking, and then we keep revealing, oh, wait a minute, that's a misunderstanding. Oh, no, that's right, whatever. We just keep adjusting the thinking. So it's a really good question. It's really good. Anybody else? Yeah, please, wrap it up.
At this point, can we just get rid of those two x's that we factored out, or for some reason we need to keep them?
We need to keep them. Yeah, here's why. Hey, we need to keep them, and here's why. In terms of the limit, they're not going to have any influence. But I'll tell you the why in a second. So, look, everybody, look. Here's another place where we get stuck. Is you know that you're supposed to factor if you can. But it's not that uncommon to encounter something that really isn't very factorable. So don't get too locked up in the idea that you're going to have to factor. When I look at that, I think that just looks harder than what I've typically seen as to be factorable. Like the leading coefficient makes it much more difficult. So I'm just going to kind of leave it for now and see what happens. If I try to finish the problem and I get close to 0 divided by close to 0, that's my warning that, oh, it probably was factorable. I got to go back. But let's just see what happens if I don't do that. So, because I don't want to waste time factoring if I can't. So now I'm going to do what Maddox asked about. I'm going to keep the x over x separate. And just leave this alone. Like that. So now we're back to where we were before. Raise your hand, please, everyone. If we're finding the limit as x gets close to 0, what is the value of the yellow box? Hands up. Brinley, what is it? So who agrees with Brinley? Show me hands. Point 2 for Brinley. Hands up again. What is the value of the orange box if we are choosing an x that is almost 0? It's very close to 0. What's the value of the orange box? For more hands. For more? Let's go with Zoe Hansen.
6.
How many would vote with Zoe? Show your hands. 2 points, 3 for Zoe. That is definitely 6. What is the value of the green box when x is almost 0? Hands up. Hands up. Let's go, Colin. 2. How many agree with Colin? 2 points, 3 for Colin. Okay, so we're in a good place now because we have numbers we know for certain. 1 second, Michael, sorry. So the yellow box is 1, and the orange is 6, or close to 6. Green is really close to 2. That means this limit is really close, or the limit is exactly 3. Michael, please.
Wouldn't the top be -6 because we have a -4?
I never pulled out the negative. All I did was take out the x, so the 6 would have remained positive. So right here, what you're going to play, you see it now?
I was thinking multiplication, not.
Oh, no worries, no worries. 2 more, please.
Why is it exactly 3?
Because it's a limit. If I were truly finding a y-coordinate when x is close to 0, the y-coordinate would only be close to 3. But limit means what is that y-coordinate getting infinitesimally close to equaling as x gets closer and closer to 0.
Okay.
So for the limit's answer, it is a solid 3. 2 more. Please, Mike.
Wait, so does that mean if you had pulled out the negative earlier, it'd be a different limit?
If you'd pulled out the negative earlier?
Yeah.
No, because this would have been -1. Like if you'd pulled out a negative, there'd be an extra negative outside. And then inside, you would have gotten -3. And -3 times -3 would have been, -1 times -3 would be positive. Two more. Okay, back to Maddox's question. Hey, whole room. If this were an AP question, it's probably worth 2 points. If you stop at this moment, you only get 1. There's more to be written. Hands up. What else must I write? There we go. What else do I have to write? Let's go, Julia Hansen. For sure. And part of that conclusion is I've got to go find the value of the function at an x value of exactly 0. 3 points for Julia. Hands up. Who knows what goes in this green box? Hands. What goes there? This is Maddox's question. What goes there, Maddox?
Would it be undefined?
Right, and that's why I don't want you to throw away the x over x. I've just seen students who throw it away and they just forget that it was ever there.
Okay.
And so I leave it there so I'm reminded that when x is exactly 0, the yellow box is exactly undefined. So up here we got this. If you knew that, give yourself 2. Maddox gets 3. And then we have this. Please.
So when there's a absolute 0, does it matter if you plug the 0 in down there where you've already factored it, or if you plug it in up there?
It really doesn't matter. I tend to feel like this is the easiest formula to work with. So I tend to always go back to this formula. But no, you could plug it in any of the 3 because they are the same formula. 2 more. Please.
Can you just write, like, since the limit f of x doesn't equal f of 0, therefore it has a removable discontinuity, do you have to have the first, like, line in there?
This one right here.
Yeah.
Oh, good question. Hey. The way I did it with my handwriting, you would get to here, and then I would just skip to here.
Yeah.
Is that what you meant?
Yeah.
Absolutely. When I typed up the answer for the back, which is where this comes from, I hadn't written this yet.
Oh, okay.
So I'm just adding it right here.
Oh, right there. Okay.
Yeah, that's all. Does that make sense? Good work. 2 more. Yeah, please, Mark.
Do we need the x equals 0 at the end because we've already put f of 0 and stuff like that?
I do believe that if you leave this off, you'll still get the points. It makes me just a little bit nervous, though, because it just doesn't feel as complete. So I take the extra 1 second to write it. Because you're right, the whole problem has been talking about what's happening at x equals 0. I just feel like it's better writing. So. 2 more. And again, because I never get the chance to walk up to the teacher after and explain what I was thinking, I want to be safe. So.
Wait, why did you cross out x equals 0?
He asked if you had to write it. My answer was maybe. So safer to write it.
That's all.
Yeah, please, bro.
So like what is 3? Is that what x equals or what y? Like
Good
what?
question. When you're finding a limit, this is the formula for finding the y values of a bunch of xy pairs. So when you evaluate a limit, you're finding what the y value is getting close to.
Okay.
The y is really close to 3 when the x is really close to 0.
But you don't ever have to write like y equals 3.
This statement right here says that. It means literally what you said, that when the x coordinate is almost 0, the y coordinate is going to be very close to 3. And when you write this, you're saying when the x coordinate is exactly 0, the y coordinate is exactly undefined. It does mean that. Does that help? 2 more, bro. Cool. Stop the video.